Okay, so yesterday I recorded this problem 853, but the problem was that I was recording different monitor and it was just not informative. So I'll solve this problem again today. Um, that gives me some like points in terms of like I'm gonna probably gonna solve it faster and will be a little bit biased for the solution as I have not like it just not popped out of the blue now. Um, I actually saw it yesterday. So um, let me describe what we have here. So this is a card fleet problem, Leetcode 853. Um, we have basically cars located at positions that are given. We have n cars, and each car is defined uh, as location. They are moving the same side to the right. They are moving to the right, and the only difference is the position of every car on x axis and the speed. And the cars, some cars can go faster, some can get slower, go slower, and whenever the faster car meets or like reaches the slower car, uh, they uh, they will start to 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 drive with the same like speed of slower car, and basically you can treat them as a single kind of point or single car. Like one group of the car and the output, so we have like a target, the final destination for the cars as like a coordinate on x-axis, and we need to figure out how many groups of cars will pass the target finish line. So let's say we have like 10 8 this array, and then we have like speed, and we have this array, and we have target equals 12. So we have target equals 12. So let's say target equals 12. So for this is position. So first of all, I'm gonna sort the positions. So position and speed array. So the position gonna be 0, 3, 5, 8, 10, and the speed gonna be, this English 1, 2, 3, 4, 0, 1, 2, 3, 4. So the speed for the car at 2 is 1. For the car at 3 is 3. For the car at 5. Oh, wait a second. I need to check. So for the car at 2, it was 1. For the car at 3, so 4, 3. For the car at 5, 1. For the car at 8, 4. And for the car at 10, 2. So we already see that like this car that the closest to the target, target is equal 12, so it's like 2 meters away from the target, going slower than the car that's behind it. And the only question is whether this car that's behind it what gonna happen first. It's either this car gonna reach the car with like speed 2 before the target. In this case, they will cross the target as a one group, or it will reach the car after the target. So it will mean that they will both intersect the target finish line separately, and they should be accounted as like different groups, like two groups. So there, how to calculate the time when it's gonna. So we already sorted array by positions and like keeping the order of speed in sync. So now I need to basically calculate the time when the, like, let's say the last car finishes like reaches the target. So I have like position 12 of the target minus 10 of this car divided by its speed, meters per second, and it's gonna be like 2 over 2 equals 1 second. So this car gonna, the last car gonna reach the target in 1 second. And also, if I calculate the car behind it, so it's gonna be when it's gonna reach the time time to target equals this array. I need to calculate when it's this car, the second to the last one, when it's gonna cross the target line. So I need to subtract 12 minus 8 and divide over its speed over 4 equals 4 over 4 equals 1. So they're gonna they're gonna meet at the they're gonna meet at the target line, and based on the like problem statement, they should be counted as a single car. So I'll repeat the procedure for the all previous cards. Like for the card position 5, I'm gonna have 12 minus 5 uh, over 1. So it's gonna be 7, 7. And then we're gonna have position 3, 12 minus 3 over 3 equals 3. So we're gonna 3 here. And then I'm gonna have position 0, 12 minus 0 over 1, speed 1 equals 12. So we already see that there is some kind of clustering. So this car will reach the target in the same time as previous car, as the next car. So they're gonna cross as one group. So this is one group. So this car is going much slower than this car. So it's if this car takes like 1 second to reach the target, um, this car gonna like take 7 seconds to reach the target. And so it's gonna and goes much slower. So it's gonna be separate group. So whenever we have this, uh, we have target when let's say ti. Let's say we have like previous target. Um and then there are two possible options. T ti, let's say minus k um, um, as uh, greater than target, and then ti minus k less or equal than target. If it's less than equal of target, then we need to just skip it and then do the let's say k plus plus, k plus plus. If that time to reach greater than target, it means that this I minus k car is basically slower than the group. So we need to increment the group counter, and we need to reassign the target, gonna be ti minus k, whatever, and then we need to do this I equals I minus k minus 1, and then we need to do the k equals Let's say I equals I minus k, and then k is equal 1. Yeah. So this is gonna be the formula, and basically I'm gonna go one by one. Here gonna be one group, then we initially group counter is equal 1. Then we're gonna transfer to this group, and then group counter gonna be 2 for this group, and then and target was for this one was 7. Target for this one was 1, and then we have another car that's going even slower than the target, the current target. So it's 12 is greater than 7. So the time to reach the target is greater. It means that this car is slower. It will not reach the current at index like 2 um, before the target. So it will be just a separate group. G3. So it's gonna be the answer, and the target in this case is gonna be 12. So in this case, the number of groups equals like 3. And the important, I made a mistake actually when I was solving the problem. So in order to track this time, I need to have a separate kind of array. Not separate array, but I'm not okay with integers. I need like double array here. Because again, um, when we're gonna divide like distance left to the target over speed, uh, nominator like integer denominator is integer, but the result can be like with a floating point. So that's why we need to hold this time to target array in double. So the time complexity for this algorithm, because I need to first sort, so the time complexity gonna be O of n log n, and actually n here is like 10 to the power of 5, so pretty okay. Plus, I need to go from the end of the array to the start of the array, so it's gonna take like O of n, and I'll have this target variable, and that target variable gonna be basically the like constant space. So for the space, I need like extra array to save the first of all, I'll save the position and speed, and then I'll sort it, and then I'll calculate the time to target. And basically, the space complexity is going to be O of n in this case. So, yeah, that's it. So time complexity gonna this we can ignore this term. So the time complexity gonna be O n log n, and the space complexity gonna be O of n. So let me try to code this one. Um, so for the code part, you already see that I have some code here. Let's just remove it as of now. So for the time complexity, not time complexity. So I'm gonna go again. So I'm gonna have like I need import Java util arrays, and then I need to do this int not double, and we have then int n equals position length, and then double. Let's say we have d variable equals new double, and then here we have like n and then 2. Um, under 0 index is gonna be the position, and one index 1 gonna be speed, and then I'm gonna recalculate it and save the time to target. So for int I equals 0, I less than n I plus plus, I need to do double I equals new in new double and then position I, and then speed I. And then I need to array sort for the for this data, and then I'll have like in double d1 double d2, and then just we need to move double compare d1, so the positions of d1 and d2. Okay, and then that's gonna be it. And then I'll go. So initially, I'm gonna have this target t. Okay, so first of all, I need to recalculate the time. So here gonna have like basically I need to do this target minus position I over speed. So it's gonna be time to target. Let's say we'll have like a double here. So this is going to be time to target already in this data array, and then I need to go like int target, say equals, so number of groups equals 1. Initially in target threshold gonna be initially dn minus 1 1. So initially the time to target gonna be the time to target, initial threshold gonna be the time to target for the last car. And then I need to go for int I equals n minus 2, I greater equals 0, I minus minus. And then I need, there are basically two choices. Choice number one, if data I 1, so it's like time to target. If it's greater or equal our current target threshold, then I need just continue. Else, if it's less, it means if it's okay, if it's less, if it's less or equal threshold, it means that the car we are currently checking is going faster than the time to target for the threshold car, and it means that they're gonna like this current car gonna reach the threshold car before the threshold car arrives to at the target. Else means that a current car is slower than the threshold car. It means that um, we need to basically update so we need to increase groups, and then we need to to update the threshold. Threshold gonna be equal d I and then 1. And then in the end we need to return groups. So let's quickly check static void test1, then gonna have this position speed. Okay, I can just go like this and speed. So the target was 12, and then speed was this one. And then should work. Test one. Uh, okay, let's run it. Okay, double. So here double. Mm, I didn't print that. Okay, so let's check this one. uh, I need to just paste the inside of this. Um, yeah, I don't know why it's not working. Why it's working like that. Um, okay. Okay, so it's 22nd minute. I consider it pass. I can definitely do the following optimization. I can just have instead of having all the sorting and like having all log n or n log n complexity, I can do the following. I can do the save the double. Yeah, I will have the double array time to target. Cause new double say n. And then I gonna do the following. I just gonna go and save at the position time to target. Oh, actually, I need not n, but not the length here. So the position gonna be target. Okay, so the target in the target, and it says basically no car can stay on the target. Yeah. So the position less than target. So we can have like just target length and then time to target for the for the position I equals like this value. And then I can like remove this one and I can remove sorting and I can just go through the target minus one. Let's say time to target length minus one minus even minus two. And here And so basically in this situation, we'll have like many gaps in this array time to target. And we can treat that gaps like time to target. This by default, those cars, like those proxy cars will have time to target equals 0. So they're gonna basically have a light speed, and they will basically go as fast as possible to the cars that ahead of them. And why I'm indifferent to that one, because like in this case we have like either we don't have car there, or like we have a proxy car that in our case works. um, it's gonna be like the speed time to target gonna be so fast, then um, we just continue. It's gonna be definitely faster than any threshold. Um, then we just gonna continue. It will not affect our result. So zeros in the time to target array, that's we're gonna say, okay, it's proxy cards that going with the highest speed possible. They're gonna, in any case, they're gonna bump into the car that's ahead of them. It's gonna be slower than the kind of this infinite speed. Um, and basically it will not make any difference because the number of groups will stay the same. We only care when actually the car behind us is actually slower than the car. So the current car is slower than the car ahead of us. And in this case, if it's slower, gonna go to this branch. We're gonna increase the groups, and we're gonna update the threshold. So let's me trash threshold here, and then let's say threshold, and then threshold. I guess T was more intuitive. T. So time to target I. So in this case, we are much more efficient in terms of like we are much more efficient. Let me think about why this is not working. Okay, so this is not working because we are definitely not in all cases gonna have like the car at like target -1. So in order to make it work, I need to do this. Uh, so I need to go max position, save somewhere the max position, yeah. Or we can actually not to do this extra variable. We can do the following. I can do time to target. So initially I can have like 0 groups, and if the so it's either way I need. Okay. So initially it's gonna be time 0. Uh, okay. So something like this. Even we even can like do this. So by default it's gonna be 0. No. Okay. Actually, we can even save on space. Here, we can do even better. Instead of allocating this time to target array, we can override the, so like this one is one improvement. The time complexity for this one gonna be time of one of, so we don't have to sort it now. So the time complexity gonna be of target, because we'll have to go through the, first we're gonna have of target plus, I assume there, um, there won't be like, if they're gonna be the cars in the same, uh, what happens if they're gonna be cars in the same position? They don't say anything about like distinct destination points, distinct like positions and speeds. Uh, I wonder why that worked actually, this sort worked. Because if we have like a car in the same position but different speeds, we need to first go with, yeah, it depends like what gonna in the case this car in the same position, two cars in the same position but different speeds. Who gonna be like ahead, who gonna be uh, behind? I can definitely introduce the ordering here, but they don't say like in this situation, it's either like the faster car gonna be a little bit uh, further and it go faster, and the slower car gonna be behind and go slower, and in the end gonna be two groups, or just the faster car is a little bit behind and it's gonna bump into the slower car, and it's going to be just one group. So they don't say anything about this one, but if they would say that, I would definitely like introduce additional like layer of sorting here, um, by comparing, if they have like, the same position, then I'll compare their speeds, whatever. Like if you have any kind of rules for that one, but they don't say about say anything about this case. So. Time complexity O of target plus O of n, y of n. No, just O of, yeah, O of n, because and I assume the n gonna be less than target, because less or equal, because less because, yeah, because a position should be less than target, then it means that the number of cars gonna be less than target also. So it's just gonna be, we can assess like O of two target, remove and here. So gonna be O of target time, and the space complexity gonna be space O of target. Oh, this is 0, or, and the space gonna be O of again target, because we need to allocate this array instead of like escaping a sort. I can definitely, let's try to paste it and check if it works. Let's first check here. Okay, so let's go check here if we're gonna save it, run it, if we're gonna improve. Mm. Memory is still not that good, but like the time complexity became better. I now do this percentile. So next, next improvement, how we can improve space. We are saving time to target into this array. What if we, um, Yeah, we need to allocate, reallocate it back and forth. Uh, yes, there is some trickery if we have. Yeah, I don't know. I don't see how we can improve it even further. This seems like the best approach. Mhm. Yeah, it seems like this one is the best I can do here. Yeah. Okay, I'm gonna wrap up. I consider that pass because I solved it on a 22nd minute. But again, um, it was I solved it yesterday, as I said in the beginning. I solved this task yesterday, but I was recording a different monitor, so like you wouldn't be able to see what I was like writing there. So I re-recorded that today. It's a little bit cheating because I remember that, but back then, just a small summary. I saved the time to target in an integer array, and then it was not working because some of we need to like floating point precision in case like we have this like like integer or integer not always gonna be like integer. That's why we need double. And here I also improved um, the time complexity. Actually, it's kind of debatable. It's either so the previous solution was previous sort based. It was or n log n, where n is a number of cars, and here like and basically uh, and time and space it was or of n, and basically here target is actually higher than n. It's bigger than n. So it's like trade-off. If 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 actually in the end like O n log n greater than target, that's a question mark here. So it was definitely greater than n when I like based on the description. Um, why don't we have wolfram alpha? Then I'll have x. So x log x. Okay, so x log 2x. Okay, you don't want to do that. Log x over log 2. Okay, let's do that without constant. Like, yeah, definitely, but it depends on the what's the constant there and here and there. Yeah, to figure out like how that's interesting graph. I thought it's like let's say so x to the power of 2 grows faster than x log x. What is this lm? It doesn't want to show me everything. I have to do everything by myself. Okay, what if ChatGPT can help me? ChatGPT, help me. Draw system. So I assume that log graph gonna be like something like this, but I don't understand. Yeah, I don't understand what it was drawing me like. Yeah, it's interesting. So logarithm is definitely going higher than just y equals x. So for as you see, um, let's say 1000. for smaller like access, like if you have like higher multiplier, okay. So like here we have like our dependency on target, so it's like different variable. Okay, yeah, ignore that. This is log. This is x squared. So like it's very close to log x log 6 is very close to x function, like linear function. Okay, that I knew that. So the question is, if you have target, let's say 10,000, like 1,000, and let's say we have um, like 900 cars. Uh, what's gonna be 900 multiplied by uh, log 2 900? So 900 multiplied by log 2 900 gonna be it's gonna be a pretty high number, much higher. So let's say we have like let's say we have 10 cars, just 10 cars. Oh, like even 100 cars. Yeah, that's ChatGPT. Says cannot calculate. Okay, let's do the so it's gonna be like less than 1,000 in this case. So for some numbers, this equation, so this approach gonna be with sorting gonna be better for some small number of cars. But as soon as the number of cars reaches the target, approaches the target, like 800 or 900, this gonna be very time consuming. So it's gonna be much bigger than this part. And let's say we have like 800 here, and then that's gonna be like better. C1 by 800 or C2 by or like let's say we have okay, C1 by 1,000 here. We have 1,000 target equals 1,000, and we have C2 let's say 800 log 800. So I say that this is gonna be much higher than the 1,000, and in this case the first approach is preferential. Otherwise, the second approach will more preferential. Yeah, what I will do here probably will have a mixed approach where I can solve it like the first way or the second way. So if I do this, let's have submissions, solutions, submissions. So if I do it was the sorting. Let's figure out if we can beat that. So let's say car fleet or target, and then we have the another one, car fleet n log n. Or target, let's change it like n log n, n log n, and then or target, and then o n log n. And then we'll have this function that's gonna just do the following. It's gonna assess the target and the position. Position length is n equals position length, and then if n if target greater than n multiplied by n. If the target is greater, then it means that we need to go O log n solution. Turn target position speed. Else, so we need to just do this as return. Then if its target is greater than their position, so then we need to do O n log n solution. Otherwise, we need to do O of target solution. Okay. Curve lead of target position speed, and then here, and then let's run it. Okay, let's remove this one, run it. Okay, let's check this solution. If so, I'll add my channel. Mm, yeah, not that what I expected. It's like average of average. What if I do sysgc in the end? Yeah, memory is better. Yeah, but this is a duty hack. What if I do like multiplied by 2? If I this multiply by 2 this side. So I want to use this. Let's say we have. I want to increase the weight of this solution. 10. So I want to divide by 10. Yeah. Okay, we are moving. So if I want to multiply divide by 100. Mm-hmm. 1000. Yeah, it stopped improve. I guess it stopped it was one. So 99.84. It was 1000. Okay, so it's a little bit improved with, and I guess it stopped improving. I guess the optimal is 100, and we do system DC in the end. 100, I said 100. What if like 50? Like gradient descent. Okay, 50. Let's do 50. Mm, 100 is still better, and we do system DC. Ta-dam! Okay, we got a little bit penalty for the. What other people are doing here? Oh, yeah, they also know this trick. Okay. Yeah, I hope you enjoyed it. I'm gonna wrap up. So, because I solved this within like 22 minutes, I consider it pass. I was then experimenting with different approaches, like can I beat it even further? It seems like experimentally I figure out like I should have this threshold 1000 or like deciding whether I should go n log n solution or just or n log n or like or target time complexity. And yeah, let's just quickly check if I didn't miss anything here. No, I didn't miss anything here. Okay, so it's like divided by 100. Okay. That's gonna be it. I'm gonna wrap up. Even if I'm gonna do this one, what I'll get, not including this tricks. Yeah, and then 1000. Yeah. So we spend more. Okay, I guess like 100 is more or less optimal. Okay, I will wrap up. Hope you enjoyed this video. I was experimenting a little bit here because I got a little bit more time for the after solving this problem. So hope you enjoyed it.